Hello explorers and welcome to another video. Today I'm gonna talk about a tool that I've been using at work for a while now, and it's called XSpec. And this is a good tool if you are trying to create XML transforms and want a framework to test your transforms in order to create something that you can reliably build upon. Many times when you're doing small incremental changes, they can have very large impacts if you are trying to transform a huge data set. So building small test cases to check your different functions could be a good thing to do. And we're gonna start by talking a little bit about how to install it. So first off, you need Saxon XSLT Home Edition. You can have another edition as well, but Home is free, so that it's one thing you can download. And then you have this Git repository, XSpec, that you can clone down to your computer in order to have the actual binary. And this is actually a script that will run your Saxon parser with the specification. So it will create an XSLT to test your XSLT code. And then you need to set either a Saxon CP class path, or we can actually set the Saxon home if you like to, and then it will look for a binary for Saxon parser. I've chosen to just point to the jar file of the Saxon 9 Home Edition. I thought that was easier. You will get an error message that you don't have the actual runtime environment, that you are running it through the class path, but I think that's a reliable way to do it. And then you just put your XSpec into your path. If you don't do that, you just have to write out the path every time. And then you just try to run your first test. And in my little example repo here that is available on GitHub as well, XSpec examples, I have this working just to test that everything is working. So if I run this command, I will get a report. And in this little video today, we are going to create a new example, an article example. And here we have a very basic first setup for XSpec, and it will generate this test report you have over here. So you have the first part here that you say we have some description. So description is the actual specification, it's the root of this document, and it has this X namespace, and it's pointing to jenison.com XSLT XSpec, and all name spaces are either implemented somewhere else or is just something made up to put things into. And in this case, it's something that is connected to XSpec. And then we have my style sheet, in this case working, but I will change that to article example, because that's the file I actually want to try out now. So I have my article example over here, and this is my specification. And we can run this again just to see that it's working, and we don't have any errors yet, so that's good. And here we see that I run it with the style sheet of XSpec example. Might blow this up a little bit so you can see that more clearly. And we have no content, so no pass, no pending, no failed, no total tests. So this report is quite uninteresting. And XSLT or XSL is a functional language, something that I learned during this process. So there are looping constructs and different ways of actually transforming data back and forth, but everything is immutable, and you are getting some input in the stream, and then you will produce some output or a few different outputs. You can produce a lot of files or just one output file. So to start off here, to create an example, we start off by creating a scenario. And this could have a label. So let's call this article test cases, and we end our scenario. This is a small little grouper, so you can actually put test in a scenario, and you can have scenarios within scenarios. So if I run this at the moment, I will actually get article test cases, and if I put some test in here, then I just have one test, and then I have my next scenario and my next scenario. But I want to actually create some suite of article tests, and then I will put another scenario in this scenario. So we just copy this, so we put one inside of the larger scenario, and we call this everything stays the same, so nothing will change. And if I do that, we can run that again just to see the output. I will get a slightly different output. Then I get article test cases, and I actually don't see this everything stays the same. So let's create the test case. That might show it off better. So I will create a context, and this could have a label. This doesn't have a label actually. It's just a context to work with. So context is the actual document that I want to run, and in this case I want to create an article. This is new HTML5 tag that you can use, but this is XML, so you can use any tags. But I just wanted to create something that have a header. This is my headline, and stop that. And then I want to have a paragraph with a strong tag. This is my ingress, and we end our strong tag here as well. And then I want to just, and lastly I want a body. So that's my body text, and this is my context, but I don't have anything that I actually test at the moment. So in order to test something, I can say that I expect something. Label. No changes. So I expect no changes here. And which goes for this context, I only put the output in my expect method. So I put this context in, and I expect this output out. And let's run this example. And everything stays the same, and we see here that I have my article test cases, I have my everything stays the same, and it's 1 of 1, success, and no changes. So that actually shows off that I have bunched my test cases into this, and I have one test case, and it's a successful one. And let's now create a scenario that will fail. So let's say that I have this scenario here, and I actually want this headline up here. This could be a paragraph, and I want this paragraph to actually become a headline. So we will change something. We take the first paragraph and create a headline of that. Let's say that we just have some flowing text and we don't have any headlines, and my article needs headlines, so therefore I want to create one. And if I run this test again here, I will get 2 tests with the same name. That's no good, but one of them will actually fail, and we will get a result down here saying that this p tag that I have as a result, I expected a h1 instead. So let's change this. See here, it was the first test I changed. That's not good. Let's change the last one instead, just so we have them in order. And my scenario is create headline from first paragraph, and we expect that the first paragraph becomes a headline. So let's run that again just to see that we have the right failed test here, and we have. Let's go into our article example here just to show the style sheet. So this is a very simple and normal style sheet. We start our XML, we say that we want to do some style sheet operations. We have an output tag that we say that we want our encoding to be UTF-8. And then we have our first template here. If we match any node or any attribute, we want to copy that attribute and apply templates on that attribute for any node or any attribute. So this just says that if you see anything, then go through to the next node and copy that, and the next node or the next attribute. So this is just a fall through and copy everything. And it's not a copy of, because if you use copy of, you will actually copy everything in that tree structure and that tree node. But by using this copy and then apply templates, we open up for making changes somewhere in the tree or somewhere in the flow. So let's create a new template here, something simple. We say that in our template, if we see a p tag like that, we want it to become an h1 with the same thing we have up here. Copy everything below, and we end with an h1. So let's see what that gives us. So now everything fails because everything becomes a p tag. And we also see that we wrap our p tags inside here as well. So everything becomes p tags. So that's not what we wanted. So let's remove that copy. Then we will probably not get the wrapper, but everything will become h1. And that's not what we want either. So here we need to actually figure out that the first tag of the article is a p tag, and if so, then we want to create an h1 of it. And in order to do that, we will look at the article first. We will match an article, and under that we want something, anything, and we want the first one of that to be a p tag. So the first thing here says if you match any node star in article, so any node in article, and I want to filter out the first node in article. So you could write the last node, or you could write the second node, or so on, but we filter out the first node, and we say that that node should be a p tag. Then this will trigger. So let's see if this will do something for us, we still have a failure. So the last is still failing. So let's see here. I think we need to put a self as well. So this is to show which context you are in. So if we have created this list, then I want to check the specific node that I am on at the moment. So I'm not doing a full operation on the full list. I do one operation on each tag. So I will check. In this case, we don't have we don't look at the full list. We're looking at one tag because we have selected the first one, but we still have a list. So we still need to say that for each, or the self node, this we are looking at moment, if that should be a p tag, then we will do this operation. So now we have actually created our first little transition, creating a headline from first paragraph. And then we go for the next scenario. And then this is a little bit harder. So let's try it, see if we can do it. The second thing I wanted to try out is if I don't have this strong tag here in my p tag, I want the second paragraph of the article to become a p tag with a strong tag in it if it isn't. So if I have a paragraph as my second, and if it contains a strong tag, then I want it to be an ingress. And I think I will go even further and perhaps say that if I have any h1, I want the next p tag to be an ingress. But we can start with this if we see that the second article or p tag is without a strong tag. So let's create another template here. We can start with actually running the test runner again and see that we don't do anything wrong here. We did. Let's see, we got we pushed it too far down. Create an ingress from second paragraph. The second paragraph becomes ingress. So let's see if this will run. And it does. And we have our failed test case again. So let's see if we can solve this one. So we could actually take this template and try just to change this up and say if the second one in the article is a p tag that has don't have, so we just have to say strong here, but we also want it to be a not statement. So we want this only to be true if the self p and strong under p is not true. Then we want to create this p tag with a strong tag, strong, and lastly strong. So only if the second thing in here, and we can also say that it should be self p and it should be missing the strong tag. So we can say that we have the same thing as up here, but it must also have this second argument here that the p strong should be missing. let's see if we solve this issue with that. And we actually did. So now we have 3 fixed tests. And then I want to do, I think this will be the last one that we try today. And let's do one more. And here I want an article that have multiple headlines, and I want the p tag after each headline to be a strong ingress. So let's see if that's working. No. Paragraph after header becomes ingress. And the create an ingress from paragraphs following headers. So let's look at that. Yep, failed test case. So now we see here that the second one didn't get this strong tag, and so my second ingress did not actually become an ingress. That means that our first little thing here will not work. So we need to have another check here. So I think we will keep this not strong tag. So the current node that we're looking at now should not have a strong in it. It should be a p tag, but it should not have any strong in it. So we just remove this first one here. So we will look at any node and say if it's not containing a strong tag, it will actually create one. So this will fail all tests because every p tag will have a strong tag in it, and that's not what we wanted, but just so we see that that logic works. So here we need to say if the current node is following a header, and we can actually say following h1 but this means that the next node, so we are looking at the next node. So if we said this, then we would say that if this node that I stand on now is a p tag and the next node is an h1, this will become true. And this will do the opposite of what we actually want. So this will create a p tag of the last body before an header. So this is not what we want either, but it's good to know that we can do this. And this is for any structure. So you're looking not at the current level and the current childs of article or any other node. It will actually transition in the tree to the next node. Following will look at all following nodes. You have also a following sibling, and that will keep in the same grouping of the nodes. So in this case, all article nodes, we look at all the following siblings of that article. But we actually want to look at the preceding. Hope that's correctly spelled. The preceding node should be an h1 in order to actually set the strong tag. So let's see if that works. Preceding. Didn't I spell it correctly? See if that's more correct. Let's see what we did now. So preceding h1. So if it has an h1 before it, it will actually be correct in this one, in this case as well. And as you see here, everyone gets a strong again, because we are looking at all nodes preceding the current node, and that's not what we want either. So we actually need to look at the preceding star, and then again the first, and in that one H1. So it should be an H1 in the preceding, exactly as we did with article. We say the preceding, all the preceding nodes, we take the first one in that list, and we are looking if that's an H1. And we still get fails here. So we didn't do this correctly. I think we forgot the self again, because we are looking at the list. Could that be the case? Yes. So now we have correct test cases again. Everything is green. So the last one, which was a little bit harder to follow perhaps, let's look at that in more detail. It says that in the article for then we have these rules. Any node in the article we are looking at, and the rules for any node in the article should be that the preceding sibling, so any preceding sibling of this article, I get a list of those and I look at the first one of those, and if that first one so I look at the nodes. If that first one is an H1, and the current node that I have in this list of article is a p tag, a paragraph, and it's not containing a strong, so self p dash strong is not true, then this match comes through. I will take this p tag and add a strong tag and apply the templates on that. So that will fix this specific issue that I have. I hope that you found this tool interesting, and this session where we created some small examples for an article and created different nodes in an article were interesting. I hope that you learned something, and if you have any things that you are struggling with in XSL and you want some help with that and can provide me with some examples, and if you think this is an interesting tool, then I'm glad to actually do more videos about this and show off how you can do some other things in XSLT and with this XSpec. And if you haven't subscribed yet, please do that. Share the video with your colleagues and friends. Give it a like, and I really hope to see you in the next one.